Good morning, everybody, and welcome to Analytics Simplified. In this series, we are talking about the different data fallacies that any data analyst and machine learning practitioner must avoid. And in this video, we will talk about Cobra Effect. So, what is Cobra Effect? Cobra Effect basically comes into picture when an incentive provided for solving a problem creates even a bigger version of the problem, which means an incentive is given to solve a particular problem, and due to its bad design, that incentive ends up creating the problem even more severe, right? In some textbooks, it is also referred to as perverse incentive. And what is the root cause of this effect? The root cause of this effect is that we have inadvertently chosen a metric and we have made it to be a goal. So whenever a metric becomes a goal, there is a strong likelihood that that particular metric is eventually going to fail the system, and then we say that due to bad design of the metric and the following up of that matrix to become the goal, cobras have emerged. Now, there's a basic telltale from the British rule in the colonial India that actually led to the introduction of this particular term. So basically, what happened was in region around Delhi, there were a lot of snakes in the city. Okay, and British government, what they tried to do was they tried to curb the population of snakes. So they provided an incentive. The incentive was that for each dead snake that the farmers or the people brought to the government, they were given some incentive. Now, the whole idea behind this incentive was to make sure that people themselves kill the snakes and the population of the snake reduces in the city. But as the luck would have had it, what farmers and people started to do was they started to raise more and more snakes so that they can kill more snakes and they can get more profit or more incentives from the British government. So after a while, when the government realized this fallacy, what they did was they stopped the incentive. And when they stopped the incentive as a revenge, what the people started to do was they started to release the snakes in the city. So this incentive was originally designed to reduce the population of the snakes in the city. However, because of its bad design, it ended up increasing the population of the snakes in the city. So that is the basic essence or the basic origin of Cobra effect. Now, in addition to this, we can always find the Cobra effect into picture multiple number of instances. For example, in 2015, US government launched a quality payment program. So the whole idea behind this program was that there was a feedback system between doctors and the patients, and depending upon what kind of treatment the customers or the patients received, they were supposed to give a feedback, and the salary of the doctors and nurses was governed by the feedback that they received. So what happened was, now this was basically done to make sure that the hardworking doctors and nurses are getting more feedback, getting better feedback, and getting better salaries. But then there was Cobra effect. Why there was a Cobra effect? Because in an attempt to please the customers or please the patients, doctors started to act the way the patients wanted. So they stopped recommending them painful procedures like this. So what basically happened was doctors and nurses, they started to please the patients without caring about their health, so that eventually they get better feedback from the patients and hence better paycheck. So this whole system, while it was designed to improve the healthcare being given to the patients, ended up having a system when doctors started to please the patients. So this was one instance when Cobra effect was seen in the US. In another application, we also find Cobra effect when software developers and testers, they start to work side by side. So basically, what happens is for each module that the developer designs, he is given some incentive, and for each bug the tester finds out, he is given another incentive. So what happened was that in this form, software developers and testers, they began to work in tandem with one another. So what developers used to do is they used to develop a small routine with a bug. They intentionally used to put a bug in that particular module, and they used to pass it on to the tester. So in this way, they have designed a module, so they are getting an incentive, and because there is an inherent bug that they have intentionally introduced into the module, testers used to find that particular bug and they used to report it. So in this way, there was a loop in which software developers and testers were able to build more modules and test for more bugs, and at the same they were able to get more incentives. But then the overall picture was that the productivity of the organization was severely compromised. So while the incentive scheme was there to improve the quality of the module and to make sure that the modules are bug free, it ended up in a closed loop when developers and testers started to work in tandem with one another, only to get more and more incentives. In another incident, we are talking about the city of Bogota. So, what was the issue there? There were a lot of cars in the city, and because of this, a lot of pollution was getting generated. Right. So, what government decided to do was they started to make sure that depending upon the registration number, only certain vehicles be allowed on a given day. Okay. So, in this case, the idea behind this scheme was that only half of the cars will be there on the streets on any given day, and therefore the pollution in the city is going to decrease. But then what was actually the case, the rich people, they started to buy more and more cars with different numbers so that they could ride every day. So while this scheme was designed to reduce the pollution in the city, it ended up with rich people buying more and more cars. More and more cars being purchased means more and more cars on the street, and eventually it led to increase in the pollution levels in the city. So this was again a Cobra effect reported in the streets of Bogota. Then in an organization there was a incentive which was based on customers first response time, like which product is able to get customers first response time. Okay, which scheme is able to get the customers response quickly. So whatever people were there, if they were able to get the customers response quickly, they were given some incentives. So in an attempt to gain more and more incentive, what they started to do was they started to have some sort of collaboration with the customers, so that customers used to give them feedback quickly. Now the whole idea is the feedback that was coming to the sales people, that was quick, and they were provided the incentive irrespective of the quality of the feedback. So even if it was a bad feedback but it came early, even then the sales people were given an incentive. So clearly this was a bad design which actually led to cobras out in the streets. Now, when it comes to data science and machine learning, we also have Cobra effect into picture. So, how it can be the case? See, sometimes what happens is when we are training a model or when we are building a model, we may end up with incorrect methods to gauge the performance of the model. The performance metrics that we choose, we may choose those metrics incorrectly, and if that be the case, we may get very strong values on those metrics, but eventually the generalization performance of the model is going to be poor, right? So what is the whole essence behind this Cobra effect in context to data science and machine learning? The essence is that when we are designing a single matrix, or when we are using a single matrix to measure the performance of a model, things will always be risky. Why? Because a single model may not be able to capture all perspectives of the model, right? And then public may not always be a reliable source of what is good and what is bad. So once you have developed an AI system and you have deployed it, so the feedback that you get from the public, that may not always be a reliable source. Okay. For example, when we talk about regression, so the metrics that we primarily use is mean absolute error and root mean square error to figure out the goodness of fit. Now, if you make these metrics as a goal, then you may end up with a model which is giving you minimum value for MAE and RMSE, but then which is overfitting. This can be the case, right? So this is a Cobra effect. We are actually trying to reduce the MAE and RMSE values with the hope that the reduced values will give us a better generalization model. But then what it turns out to be, it turns out to be a model that is overfit. So our initial objective was to reduce this MSC to get a better model, but eventually what we are getting is we are getting a model that is overfitting. So again, this is the case of Cobra effect in context to data science and machine learning. Similarly, when we talk about classification, there are different metrics. For example, you have precision, you have recall, you have sensitivity, and you have F1 score. Let's say you choose precision to be your performance metric. Okay, so in some applications you may get very high precision values, but then the recall for that particular model may not be that good, right? The same thing could be between recall and sensitivity, right? So the whole point I'm trying to bring out is, if you rely on a single metric, then chances are that you be able to optimize on that particular metric and still get a model that is not generalizable. Okay, so if that be the case, if you are encountering such a situation, then that the metrics that you have chosen, they are reporting very good values, but still the performance of the model is not generalizable, you simply say that there is a Cobra effect at the back end. Okay, So to summarize what we have talked about for the regression and classification task, we can simply say that when ill chosen metrics are proxy for success, there is a Cobra effect at play. Okay. Now, what are the different avoidance strategies that should be adopted to make sure that Cobra effect does not come into picture? First of all, metrics should never be seen as sacred, right? If you have some metrics like mean absolute error or root mean square error or anything like precision recall, you must not think it to be godlike. You must always view it as a metric that may not be applicable in all the application scenarios. Okay, so this is the first avoidance strategy that must always be involved. Okay, the thing is, you should never idolize any metric. Then individual evaluation of metrics needs to be coupled with group evaluations of metrics. The same thing, if any metric should not be thought of as godlike, so it's always a better idea to have two or more metrics, and then you figure out what the values are reported for each of those metrics and then take a decision accordingly. The idea is the final decision must not be based on the values reported by a single metric. Okay, and then if the case be or if the need be, then metrics should also be analyzed from different perspectives or contexts to figure out their utility, okay, in a given application domain. In addition, I am providing you with some pro tips that will help you avoid Cobra effect. Okay, the first thing is whenever you are creating an incentive, make sure that the incentive that you create is as simple as possible. Why? Because the more complex the incentive, the more loopholes it will carry with itself, and more the loopholes it carries it with itself, chances are it will be compromised more severely. And then you must also keep an eye on bad incentives. Because what are bad incentives? Bad incentives are those incentives that are giving you models which are not generalizable, even when metric values are reporting some very fancy values. And then the incentive must also be adaptable. You should not fixate on a given metric or a given incentive. You must always have a provision to make sure that the incentive be adaptable. For example, when the model is deployed in a real time, so more and more data will be collected, and chances are that after a fixed duration of time, that particular model will also be retrained and then used again. So in those kind of situations, because there is good amount of changes taking place in the model, so obviously the incentive that is governing the performance of that particular model must also be adaptable. And in case you have any doubts, you must always diversify. That means you must always have more than one metric to figure out the performance of the model in the real time. Okay, so with this, I hope you have understood the basics of Cobra effect, and I leave you with an expectation that in future you will be able to spot Cobra effects in context to machine learning and data science. With this, we come to an end of this session. I hope you have learned something new. Feel free to share this with your friends.